Hi there. Did you know that when light from the sun is obstructed, certain parts of the world see beautiful things happening in the sky? For example, when the moon obstructs light from the sun, some parts of the world are able to see a total solar eclipse. During a total solar eclipse, darkness is experienced during the daytime. It's very surprising if you experience one. On the other hand, we've got a total lunar eclipse. In a total lunar eclipse, the earth obstructs light from the sun, and during one, nighttime is brighter than normal. This is Z Online School. In this video, you and I will be looking at types of eclipse. We're going to do this in a systematic way, and by the end of this video, you should be able to know what is a solar eclipse, what is an annular eclipse, what is a lunar eclipse, and at the end of this video, we've got some bonus tips for you. So make sure you watch this video till the end to get the maximum value out of it. Like you already know, we're going to be starting with looking at a solar eclipse. A solar eclipse is just that eclipse where we have a new moon in front of the earth and obstructing the sun. So we can define it as an eclipse where the new moon totally or partially covers the sun. The moon is smaller than the sun, but because the distances between the sun and the earth, the moon and the earth, are very large, so when we look in our skies, they look considerately the same size. It's like you get a very big object and you look at it from afar. You might think a person is even bigger than that object. Now let's understand how a solar eclipse occurs. Of course, we have the sun, the earth, and obviously the moon. All this is made possible because we have light rays. And if you can remember, we said that light travels in straight paths. So basically, what you should understand is that we'll have rays from the sun hitting this moon and they'll cast a shadow like this. However, if we think of it more from a scientific point of view, we can't really be sure if all the sun's rays that are coming from the sun will obviously be parallel like this. It's best that we take some extremes from where these light rays can come from. So apart from just this representation of the solar eclipse, we can think of it if we have rays from the top and bottom that pass like this. It means if we've got a light ray like this, the shadow of the moon will come in this direction and obviously be casted like that. However, from the bottom again, we'll have another ray that will come like this. Therefore, that shadow that was coming here will be lit up. Therefore, the part in the total solar eclipse where we have the greatest shadow is here. You can see there's not much difference from the one we had, but that's a very key difference. The part here in the middle is where we can experience a total solar eclipse. And when we say a total solar eclipse, it's when the moon fully covers the sun. It will look something like this. There will be a black shadow covering the sun, and that's why it becomes dark. In physics, this black shadow is referred to as an umbra, or you can refer to it as the umbra. Apart from the umbra that we can see when we're in the path of totality, we can also see partially the sun and the moon at the same time. That's what we term as a partial eclipse. And what causes that is simply when a light ray, for example, comes from the bottom here and then passes at the top of the moon. So what happens is if there's a person somewhere here, they'll be able to see the whole sun, and so they won't be able to see any eclipse. But as they start getting closer to the path of totality, they begin seeing the moon partially covering the sun. Sometimes this might be even hard to see. The difference is not very visible unless you know that an eclipse is occurring. But yeah, we also have the partial solar eclipse. As you can see in this diagrammatic representation, we've got this black shadow partially covering the sun. This space left here that allows the sun's light to be seen will be still very bright, and so it will be just a small change in how the light during the day looks like. This kind of shadow is known as a penumbra. I think that should be just partial shadow. Yeah, umbra is the full shadow, and then this same thing can happen at the bottom. A light ray from the top comes, passes at the bottom of the moon, and then we are going to see no eclipse if we are past this ray. But as we get closer to the path of totality, we can observe a partial eclipse. The difference is just that the diagram is a bit changed. This also is referred to as the penumbra. Now let's look at the annular eclipse. The annular eclipse is just another kind of solar eclipse, but what is special about it is that it is a solar eclipse where the moon does not cover the whole sun, and that is caused because the moon is further away from the earth. In illustration, it will look something like this. We're going to have the sun and still the earth and moon in this same fashion, but as you can see, if you really looked at the previous diagram, the moon was somewhere here. Now it's somewhere here, so there will be a difference in how these rays of light will cause a shadow on the earth. From the start, just like we did, we're going to experience a shadow here. If there's any light coming straight from the sun, you should be able to notice that. And now, because we're going to experience a shadow in this region like this, what happens is this. Get a close look at how these rays, after they crisscross, go beyond the bounds of the shadow. So we have this shadow here, which is the center like this, and then because these rays have crisscrossed like that, they'll be able to move further and get bigger like that. And so this region here between the ray and the shadow here is this ring that will be formed around the moon. And that's how an annular eclipse basically will occur. It should be noted that all these diagrams we're using to illustrate are not drawn to scale. The distances between the sun, the earth, the moon, and the earth are very large. So if we were to start trying to draw those things to scale, you might not even see the moon when I'm talking about it. But yeah, they've been brought close so that we can just get an idea of how everything happens. With that said and done, now it's time we looked at the lunar eclipse. The lunar eclipse is the odd one out. Like we have the solar eclipse and then the annular eclipse, which is also a kind of a solar eclipse. But now the lunar eclipse is where we have an eclipse involving the earth covering the sun, and then only refracted light reaches the moon. And now, because the light that is being given off by the moon, or simply the light that is being reflected by the moon, is not really light from the sun, the moon won't look white in color. After light bends, which we'll cover under refraction later in another video, we'll see that it forms a group of colors known as a spectrum. And now that spectrum, when it hits the moon, the colors that reach the moon will look reddish in color, and that's why we have that moon commonly referred to as the blood moon. Let's look at an illustration to get an understanding of how all this happens. We have the sun. This time the earth is what's in the middle, and then the moon is behind. What you should note about the lunar eclipse just from the start is this. If we have the earth like this, the people on this side of the earth are having daytime because they are receiving that sunlight, but the people on this other side are having nighttime. And now let's draw some rays. So we'll have these two like this, and then we might also have the rays that come from the bottom and go past the top of the earth like that, and the same from the top. If the moon is here, obviously no one on earth will be able to see that eclipse. If it's also past here, no one. If it enters these regions, it means partially it's on the nighttime side, and so some people might see a partial lunar eclipse, and then in this region also they might also see a partial lunar eclipse. This is the region where we can experience a total lunar eclipse. For illustration purposes, I've added this simple gradient of colors to enable you to see what happens to the colors of light after it's been bended. The bending is caused by the atmosphere of the earth, if you've been asking yourself. If you know a bit about refraction, the densities of the atmosphere are different because obviously we have places that have got higher temperatures and lower temperatures, and when we've got different densities and light passes through those different densities, its speed changes as it passes through a certain density, and that's what causes the bending of light. And now light will bend in a certain fashion that will enable the red light to hit the moon. What becomes the result is that our moon looks this color. You can see the resemblance between these colors here and how the moon appears. A lunar eclipse can be seen at least in your lifetime. If you live maybe even up to 50 years, at least you'd have seen a lunar eclipse occur. And like we said in these other portions, the probability is having partial lunar eclipse. You have successfully reached the bonus tips section. In this video, we've got 4 tips for you, of which the first are some terms you need to know when you're talking about the solar eclipse. The first term is the Bailey's beads. These structures here is what we're calling the Bailey's beads, and if you see, they resemble small beads. Now, just after the Bailey's beads, when you're observing a total solar eclipse, there's what we call the diamond's ring. If you look at the diagram here, you see that it's a very bright speck of light. What comes first is the Bailey's beads. Then as the moon is moving and covering the sun like that, what happens is these Bailey's beads will keep disappearing one by one, and now that last Bailey's bead is known as the diamond's ring. Tip 2 is about the path of totality. I'm sure you heard me use this word. What is it? Well, this is just the track of the moon's shadow on the Earth's surface. In this diagram here, we've been shown the path of totality for an eclipse that happened some time back. Anyone in this region has a chance of seeing either a partial eclipse where it's a bit faint and a total solar eclipse where there's a dark line. And now in tip 3, we're talking about the revolution of Earth and moon. We talked about the moon revolving around the Earth somewhere in this video, and if you don't know what that is, well, this is the tip for you. The moon revolves around the Earth for a period of like 29 to 30 days. So in a period of 1 month, the moon will have revolved around the Earth once. The moon's revolution is one of the reasons why the moon looks different every night. It's moving in its orbit, and then light is striking the moon at different angles, and therefore the shadows that are created are different. We have the Earth on its own axis, but the moon's orbit, which is elliptical, is at an angle. The angle here is 5 degrees. And this angle is very important in making all these eclipses different, occurring at times of the year that are quite surprising. From the top, the moon's orbit will look something like this, and it will be revolving in this fashion, as you can see by this simple animation. The Earth is not exactly at the center, it's off center. On the other hand, we've got the Earth's revolution. The Earth revolves around the sun for a period of like 365 to 366 days, which is just 1 year if you think about it. We've got the sun and the Earth, and it's orbiting around the sun just like that. What you must note is that the moon at some times of the year will be exactly in front of the Earth, and that sometimes will be exactly behind the Earth. This is when an eclipse can occur. That brings us to tip 4, which are elliptic seasons. Elliptic seasons are just times of the year when an eclipse is likely to occur. One thing you must note is that an eclipse occurs somewhere every year, but only once every 400 years in the same place. Practically, it's close to 400. To understand an elliptic season, let's try to use an illustration. We've got the sun here and an imaginary straight line. When the sun, the moon, and the Earth are in this line, then an eclipse can occur. So the Earth will be moving in its own orbit like that, and then we have the moon moving in its own orbit like this. So when they're in the same line, which is this black line, an eclipse can occur. So the time of the year when the moon is likely to align in the straight line with the Earth, that's what we call ecliptic season. If the moon is in this fashion, we'll be expecting a solar eclipse. However, if the moon is behind the Earth, we'll be expecting a lunar eclipse. Thanks for watching till the end of this video. Now it's your time to look out in your skies to see if maybe you are lucky to see one of the solar eclipse or a lunar eclipse.